Number 3, we want to find the center and the radius. We're going to go ahead and try to put this equation in standard form. The first thing I want to do is divide every single term by 2 to get rid of the leading coefficient. Once I divide by 2, I'm going to get rid of those coefficients. I'm going to group all the x's together. As you can see, this is the only term that has an x in it, it's x squared. Now I'm going to move on to the y's. This is a term that has a y squared in it. This is a term that's 3 over 2y. I'm going to leave some room to complete the square. The z's. This term have a z in it. I'm going to put it in here. That's a z squared. This is going to be negative 5 over 2z. And I'm going to leave some room to complete the square. And on the other side, it's equal to negative 1/2. You see this is positive 1/2. I want to put it on the other side to make it negative 1/2. Completing the square. What term complete the square? 3 over 2 divided by 2 is 3/4. The square would be 9/16. If you added 9/16 here, remember to add 9/16 there. 5 over 2 divided by 2 is 5/4. 5/4 square is 24/16. 25/16. If you add 25/16 here, make sure you do the same thing on the other side, adding 25/16. Putting this in perfect square, it will be x squared y plus 3/4 squared plus z minus 5/4 squared. And if you add all of these together, you are going to get an answer that's called 26 over 16. Okay, the center will be 0, negative 3/4, positive 5/4. The radius will be the square root of 26 over 16. You're going to have to reduce it a little bit. The top, it doesn't reduce. You can leave it as square root of 26. The bottom square root of 16 is 4. Good thing that you don't have a radical on the bottom, otherwise you would have to rationalize it. Next, we're going to go to number 4. This AB is the diameter of the sphere. To find the center of the sphere, you do the midpoint. Add the x's, divide by 2. 1 minus 1 divided by 2 is 0. Add the y's, 2 minus 2 divided by 2 is 0. 3 plus 4 is 7 divided by 2 is 7 over 2. That's the center, the midpoint. The radius is the distance from the center to either point. So I'm going to do the distance from the center to point A. And in that case, it's going to give you 0 minus 1 squared, 0 minus 2 squared, and 7 over 2 minus 3 squared, which is going to give you 1/2 squared, which is 1/4. Okay, so this is 1 plus 5 plus 1/4 is going to be 5 plus 1/4, which is going to give you square root of 21 over 4. If you reduce it, it'll get you square root of 21 over 2. That is the radius. Knowing this center and the radius, let's go ahead and write the equation of the sphere. The equation of the sphere is going to be your x squared plus y squared plus z minus 7 over 2 squared equal to the radius square, which is 21 over 4. Okay, let's go to number 5. To determine if these 3 points are collinear, I want you to find vector AB and vector AC and see if you can put them in component form. Check to see if they're parallel. The first vector AB, do terminal minus initial on 3 components, and you'll get negative 3, negative 1, negative 2. Vector AC is going to be 6, 10, and negative 4. As you can see, if you look at 3 over 6, is not going to equal the ratio negative 1 over 10. It's not equal negative 2 over 4 over negative 4. Therefore, they're not parallel. The points are non-collinear. Now, because they're non-collinear, I need to find the vector, the angle between the two vectors. So to find the angle between the two vectors, here what I want you to do, the dot product, AB dot AC. The dot product is going to equal 18 minus 10 plus 8, and the dot product is equal 16. The magnitude of AB is going to give you the square root of 14. The magnitude of AC is going to give you the square root of 152. And now to put it together to find the angle, so the angle is going to be cosine of theta, or theta equal cosine inverse of 16 divided by square root of 14 times the square root of 152. You go to your calculator, make sure it's in a degree mode, estimate it to 2 decimal places. I have 69.7 degree. As long as you're close enough, you'll be fine. That's number 5. Finding a unit vector orthogonal to W and V, we're going to have to find the cross product. Cross product gives you a vector perpendicular to the V and W. So I'm going to put the I, the J, the K. I'm going to put 1, 3, negative 2 here, negative 2, 1, and 3. I want you to expand. Remember to change the sign here on the J to negative 1. And when I expanded here, I found this to be 11I plus J plus 7k. Now what we want to do, we want to take this vector and put it in a unit vector. To make it a unit vector, I have to find its magnitude. The magnitude is going to be the square root of 11 squared plus 1 squared plus 7 squared. This is going to add up to square root of 171. Square root of 171 doesn't reduce. So the unit vector that is orthogonal to both of them, U, V, and W, is going to be this vector. It's going to be, you can put it in linear combination form, you can put it in component form. 11 square root of 171 over 171. This one is going to be square root of 171 over 171. And the last component will be 7 square root of 171 over 171. Done.